Hey guys, hope you're doing well. So what we're going to talk about today is energy. And with that, we're going to talk mainly about electricity and kind of see how energy that you just read about, renewable versus non-renewable, how that works with electricity. So I figured to take this time to show you how electricity is being formed. So let me show you the basic idea of how electricity is being formed in most of these methods. So if you have a magnet, watch what happens if you move a magnet through a coil of wire. Hey, so this is pretty cool. As a magnet moves through, it does something that causes electrons to move, and you get that. Now, if it just stays there, it doesn't do anything. But as a magnet is moved through a coil of wire, this is called a generator. So it generates electricity. So this is kind of hard to do with my hand, so it kind of gets tired. So what we can do is we found different ways to harness, instead of physical motion, we're able to harness other things. So here's one. I'm able to use electricity to spin a magnet, and as that magnet spins, it causes the electrons to move. So a generator, how a generator works is two ways. You're either pushing a magnet through a coil of wire, and that produces electricity, or you're spinning a magnet near or inside of a coil. But it's all about the movement of a magnet on the coil of wire. I guess you could also do it the opposite way. Let's see if it'll let me do this. And take the wire and move it over the magnet. As long as there's some net movement between those, you can see. Also, it's kind of cool. The more loops you have, the more light that you get. Right? Also, in size and these types of things. These are some things if you go on and you want to study this stuff, this really interests you, you can go into this a lot more. But we're just showing you the basics. If you move a magnet through a coil of wire or spin a magnet near a coil of wire, you get electricity being produced. And so we're going to look at all these different types today. Now, one other thing with electricity is even in things like cars, right? In a car, you still need electricity. Even though we're burning fossil fuels, you still need electricity a lot of the times to power it or how to start it. So how does that work? Because your battery can die. So you need other things. And what you need is an alternator. Right? So an alternator is this piece of equipment in your car. It looks like this. Right? And if you notice, let's see if this will work. If I zoom in here, you can see something right there that's a coil of wire. Right? And so you have that coil of wire. So just like we saw before. So an alternator has a coil of wire. And on the inside, there's the coil of wire. On the inside, you have a magnet. And so what happens is there's a belt, and that belt spins, and then it moves this outer piece, and then that spins the magnet on the inside. And so again, we're right back to getting electricity. Now, instead of lighting it up, that electricity goes and stores it in your battery. And this is why if your car ever dies, you need to leave your car on for a while. Because what's happening is that the gas being used up, that fossil fuel, then spins parts of your car and then produces electricity, and you need to store that electricity. So if you're going to jump your car, make sure you leave it on for a little while. And so that's what a generator does. All right, let's look at some other things. So now let's take a look into a hydroelectric dam, because I know hydroelectric energy was one of our types of renewable energy. So if we look here, this is what's going on with a hydroelectric dam. Right? So they build the water up really high over here. Right? As you can see in some of these pictures that I have, it's extremely tall. How the water is, that it's just insane how much water they have on a lot of these. So look how deep that water is. So then that water drops down, goes down, and it spins a turbine. Right? And that then has a generator. And again, we're just going to keep coming back to this over and over. That water falls down, and this is what it's going on. When it's in a generator, you have a magnet spinning and a coil of wire. And they may have a lot more coils. Like I said, watch this. I get more coils. I get more electricity or more volts coming off of that. So there you can see that. And if I go down less coils, it doesn't move as much. Okay, and so you can do all kinds of different things where you're adjusting these to try and get more. Hey, but we're focusing on that. Again, more water falling faster, so that's why you have a taller dam. Like you can see, whoops, over here, you're going to have a lot more stuff going on. Right? So that's hydroelectric. Some of the negatives, again, you can research those, but they mess up environments. They flood things behind. Okay, because if you look at this one, look at all this that should have water down it, or maybe maybe this is how much water it should have on one side, just this tiny little stream, and they've backed it all up. So you can see that there. The other method, we have geothermal. So geothermal is, again, using heat, turning water into steam, and that steam is moving a turbine again. Now we've seen this one in class before, and this is the example right here. So instead of, I don't know what you're using, you could use fossil fuels, but that's non-renewable. You could use what we just saw here, geothermal. So you're using the heat in the Earth's core to heat up water. That water turns the steam, spins something, and again, whenever you're spinning something, you're back to this. Okay? You're spinning a magnet or you're spinning a coil, and you're producing electricity with a generator. So all these renewable resources are all doing that same thing roughly. Okay? Again, we saw this one before. You could do it with a bicycle. Okay? And then the person is doing the energy. So these are all these different types, but that's what we have going on with geothermal. Nuclear also does the same thing. Back to this. Instead of geothermal, instead of burning fossil fuels, you're having a nuclear reaction, heats water, water turns to steam, and then that water can push on different things. So that's what we have there. A wind turbine also does the same thing, but let's take a look and show you a quick video of seeing how a wind turbine works here.
The turbine. On the top, there's a weather vane that's connected to a computer to keep the turbine turned into the wind so it captures the most energy. Now, the blades are attached to a shaft, which only turns about 18 revolutions a minute. And that's not nearly fast enough to generate electricity by itself. So, the rotor shaft spins a series of gears that increase the rotation up to about 1,800 revolutions per minute. And at that speed, the generator can begin to produce electricity.
And so that's really the only big difference here with the wind turbine that I wanted to show you, that this does some engineering where you just switch from a bigger gear to a smaller gear, again, to make everything happen faster. So, as you saw in the simulation, when it's going slower, there's not very much electricity. So that's how much a big wind turbine, it doesn't spin that much. But if they switch it down with those different flywheels that we said, I don't know what they're called those, the faster you have it, the more energy. So that's how we have a wind turbine working. The next non-renewable type, renewable type of energy is solar. And solar has some pretty interesting ones that I wanted to show you guys about. So let's take a look at this one. There's a couple of different types of solar. So this is one that harnesses sun to do the exact same thing, heat up water and turn it into steam. Well, let's take a look here and see how this one works. Well, let's actually flip this. Let's take a look and I'll show you what this one looks like before we go into it. Those are some drone footage. There's one in California and one in Morocco. I'm not sure which one this is, but as you can see, there's all these mirrors just everywhere out here, and they have these mirrors tilted at an angle. And the next video will explain that. And they're going, and all that sunlight. See how bright this is? They focus onto that, right? And they focus there, and they turn water into steam, and that way you can see the heat coming off of those. And then again, you just have a generator like we've seen over and over again. One of the negatives, and you'll see apparently some birds have been flying through here, and the birds have been catching on fire mid-air because that's so powerful of light focus there. Okay. So that's some really interesting pieces on that one. Let's look at the explanation of how this thing works. Watch a couple pieces here.
Concentrated solar power produces electricity from the heat from the sun's rays. It's an effective source of large-scale energy production. Firstly, a solar farm is made up of heliostats. These are computer-controlled mirrors which follow the movement of the sun in order to best reflect its rays towards a central point throughout the day. Heliostats can be positioned individually, take up little space on the ground, and adapt to the shape of the terrain without requiring heavy foundation work. The farms can include from several hundred to several thousand heliostats, which communicate with each other over Wi-Fi in order to optimize their yield. The tower is located in the center of the field of heliostats. On top of this tower is the boiler. The sun rays, reflected by the mirrors, focus on the receiver and make it possible to achieve heats high enough to turn water into steam.
All right, and so there you go, doing the same thing we've seen just over and over and over again. There are some other types of solar cells, but we're running long on time, so I won't go into those. But essentially, those are just using sunlight to hit, and I'll link a video below if you guys want to see that, of how they do that. But there's a lot of other ways to use solar energy that you can have there. Problem is, if it isn't sunny, you don't have that energy, so there's some issues. How I wanted to end this unit was, what do we do about places that don't have power grids? And so let's look at that. Right? So let me show you some ideas some other people are coming up with.
Relationship between the two countries and an impact on the nation.
My name is James Aja Ichi. I am the proprietor of Aja Villa Community Academy. We're in a remote area. Infrastructures like road were not constructed. We find it difficult to have access to education. I decided to put my interests, my resources, my wisdom to educate the masses. Without education, we are nothing.
W-I-N, win. W-I-N, win. H-A-T, hat. H-A-T, hat.
The most striking thing that we need in this environment is light. When there is no light, how do you read? We have no option than to use generators. The end product of generator is carbon, and its fume in nature is dangerous. Light is life. Where there is no light, no life.
All right, so as you can see, there's some huge benefits here to having light. So how can we support countries like this who don't have that? Another thing we can think about, even though times are very difficult, how we have it so much better. As you can see behind me, I have this light. I'm able to do resources. I'm able to continue to better myself, even in very difficult times. Right? So again, they're trying to show you some more with socket. And this is something I'll show you the link, but I won't make you watch it all. But there are some other options to try and help these people of what they can do. Fast forward through some of this. So let me switch forward to show you how this works. Right? So here this girl will explain how this socket soccer ball works.
And so we chose socket, and using kind of like a basic physics, high school physics understanding of knowing when things move, there's energy, we went from there. The idea is that you have this metal coil that's wrapped around, and you have this magnet that goes back and forth inside of it.
So again, here's our generator. As that goes back and forth, it's going to store energy, and they're going to have...
The ball rolls, the magnet going back and forth generates energy and stores it in a capacitor. And the capacitor is like a very lightweight, simple battery. And then that's connected to an outlet, and you can plug something into it, and the power comes out.
I would like plug it in.
Above all, is a symbol of what can be done by people who think that they can't do anything.
So you can see this person using that, just like all those things, and they wanted this in Africa for countries so the kids can be able to learn. They can play soccer at recess, and then they can go and read at home. So this is kind of a dual product that it's fun rather than some ones that we've seen in class before, having to ride your bike to get light. That may be kind of hard. So if you have something that stores that energy, you can come up with that. So those are some other options. If you get bored over the week, a great movie to watch right here, The Boy Who Harnessed the Wind. It's very similar. A boy who tries to figure out, using science, how he can help his family, and he harnessed the wind to do that. Again, pray that all of you guys are safe. Hopefully you get something out of this and learn about renewable and non-renewable energy and how electricity works. Can't wait to see you guys soon.